The key to solving arithmetic sequences ended up being solved. We often needed to find D, so that was fairly important. For geometric sequences, the R is just as important. There's an analogy between the R and the D in arithmetic sequence. So first of all, let's find a general formula for R from the Tn and Tn plus A. So if I look back here, this was my T3. This was T6, this was T3, and the number of steps between T3 and T6 showed up as an exponent here. Okay, the number of times we used R. And then we ended up using that difference of the number of steps as the root to find R. So if I were to find R, I could do this. R is equal to, and I can just start it out this way, Tn times R, and if I use R a number of times, I end up with Tn plus A. The number of steps from n to n plus A is just going to be A, and that's how many times I use R. Now if I rearrange this formula, I can divide both sides by Tn, like this. And this generates a formula of R to the power A, and A represents a number of steps. This represents the number of steps, or the difference between n and n plus A, and that's equal to Tn plus A over Tn. Okay, so we can write it like that. I can give you an alternative formula, which is exactly the same, and it looks like this. R, if I have Tn over Tm. So the number of steps between m and n is going to be n minus m. The difference between the numbers here represents the number of steps I use to get from Tm to Tn. So this formula is very similar, because when we have an arithmetic to the arithmetic series sequence formula, in that the arithmetic sequence common difference D was really the change in Tn over the change in n, or slope. Tn minus Tn, we'll write it as m, over n minus m, the number of steps between the nth term and the m number term. And we could find the common difference this way, and it looks like the slope formula. For geometric sequence, it's different because it's not the same as slope, but there are some analogies here. The common ratio is going to be, common ratio used is going to be used a change in n number of times, and that's going to be the Tn, instead of minus, because it's multiplication, we're going to divide. It's going to look like that. So this represents the change in m from m to n. So I'm going to, how should I write this? Maybe I'll write this as n1 and n2, and write this as change in n. And we can also rewrite this as the change in n, and this is m and n. Okay, so that's going to be shown by m minus n. Actually, maybe I'll do the same as both sides here. Just switch those around, n and m, and we'll do it the same as the arithmetic sequence, n minus n. So the difference in the term numbers represents how often I use the ratio, just like this represents how often I use the difference. And we can then divide to get the ratio. Here we subtract to get the difference. So this is why it's called a common difference, and this is why it's called a common ratio, because we use a ratio here, we use a difference here.